In this lesson, we will cover Unit 3, Section 4.1 to 4.2, Rational and Irrational Numbers. In this lesson, you will learn how to explain the meaning of a radical and its parts, define the index of a radical, how to determine between rational and irrational numbers, a look into the real number system, and how to estimate irrational numbers. Before we get started with the rational and irrational numbers, let's look at what is a radical. A radical is an expression that has a square root, a cube root, or etc. It could be a fourth root, a fifth root, and it can continue on. We can have roots including the nth root, which uses a notation where n is outside the radical, and n, as you can see, is called the index. The index tells us what kind of root we have. If it's a 3, we have a cube root. 4 is the fourth root. 5, the fifth root. If there is no index, then we have a square root. The number under the radical symbol, or the root sign, is the radicand. For an example, 27 is the radicand here. 3 is the index, and all of those parts will make a radical. Now, what is a rational number? You may remember looking at rational numbers in a little bit of detail back in grade 9. But first, let's refresh our memory. A rational number is any number that can be written in the form of a fraction. For an example, m divided by n, where the denominator cannot be equal to 0. M and n, the numerator and the denominator, are integers. So it can be a fraction, or it can be a decimal that will terminate, stop, or repeat. If it is neither one of these, it can be a radical that has a square root, a cube root, and so on. But it's important to note that it must be a square root of a perfect square and a cube root of a perfect cube. Some examples could be a negative 1.75, 3/4, or the square root of 9. So if our number does not fall into one of those categories of a rational number, maybe it is irrational. So an irrational number is any number that cannot be written in fractional form. So it cannot be written as m divided by n, where m and n are integers. If it's not a fraction, it could be a decimal that does not terminate or repeat. So it cannot repeat the same digits, but it will not terminate or stop. It will keep going. Pi is a very good example of this. Lastly, it could be a radical that does not have a perfect square or a perfect cube number, and that will mean it is irrational. An example of those would be the square root of 2 or the cube root of 21. We cannot take those radicals and find the answers to be a whole number. They will be decimals that does not terminate or repeat. Rational and irrational numbers make up the real number system. As can be seen on the left-hand side, the rational numbers include integers and natural numbers. Rational numbers, again, fractions, decimals that terminate or repeat the same digit, positive or negative integers. The irrational numbers are on the other side by itself. Irrational numbers, again, are not fractions, are non-terminating decimals, are square roots or cube roots of non-perfect squares and non-perfect cubes. Irrationals are in a category by itself. However, irrational numbers, rational numbers, integers, natural numbers, whole numbers, they all make up the real number system. What if we want to approximate the value of an irrational number? Rational numbers can easily be found. For example, the cube root of 8 is 2. The square root of 25 is 5. Those can be found quite easily because we know they're either a perfect cube or a perfect square. However, irrational numbers are not quite as easy. Similar to what you did in grade 9, when you didn't have a perfect square, you had to approximate. In grade 9, you used lower and upper benchmarks to approximate square roots or cube roots of non-perfect squares or non-perfect cube numbers. The strategy can be used to approximate the nth root of any irrational number. For an example, if we want to approximate the square root of 21, we will look at the perfect squares that it's closest to. Square root of 21 is in between the square root of 16 and the square root of 25. The square root of 21 would be closest to the square root of 25, which would mean it would be closer to 5. Therefore, the square root of 21 is approximately 4.6. In summary, make sure you keep in mind that irrational and rational numbers are quite different. Rational numbers can be written as a fraction, a decimal that terminates or repeats, or perfect square or perfect cube numbers. On the other side, we have irrational numbers. Fractions, numbers that cannot be written as fractions, a decimal that does not repeat or terminate, and non-perfect squares or non-perfect cubes.